Welcome back. So in last lecture we discussed about the negative and positive loops or feedback. So how the one system is affecting the another one. Similarly, as I was talking in one of the lectures, previous lectures, that humans will also influence the system, Earth system. And one of the reasons for influencing the Earth system is the humans are influencing Earth's external geological processes, and that is because of the increase in population. So what has happened is that we have the tremendous increase in population, and we are altering to some extent the environmental conditions that are prevailing surrounding us. So this picture shows the overload in a car, and this is what's similarly happening in the present day world. Population is tremendously increasing. Now this chart, it shows the increase in population over the time from 1830 till 2010, but more must have increased definitely, for sure. So the increase in population, even for India, if you can see, it is going very high, and this is the world population total. Now this is one of the example which I was talking about, that could tell us, and there is a lesson to learn from this example, which shows that if we alter the overall environment for our needs or benefits at present, but in long run it can result into the devastation. So this is the Aral Sea is dying because of diverting waters for irrigation. So this is diverting water for irrigation. So Aral Sea was been fed by some major rivers, and the construction of the dams were been constructed on that, and the water was been diverted for irrigation purpose, and that resulted into depletion of the water level in Aral Sea. And you can see the condition that the ships are lying on the floor, sand floor. So the Aral Sea, which is located between Uzbekistan and Kazakhstan, formerly the part of the Union of Soviet Republic, was prosperous tourist vacation spot in 1960. Water diversion for agriculture nearly eliminated the Aral Sea in the period of only 30 years. Just in 30 years, this area was subjected to a dry bed. Further, diversion of two main rivers that fed the sea, that is Aral Sea, has resulted in drop in surface elevation of more than 20 meters and loss of about 28,000 square kilometer of surface area. So the lesson to be learned from the Aral Sea is how quickly environmental damage can bring about the regional change. So this has brought like change in the landscape completely. So sea which existed is now seen as a dry bed. Now some attempts have been made with water conservation of the river water. More water is flowing in the lake. So the Aral Sea is a big lake, very huge lake actually. So they have started flowing the water into the lake, and the dams keep the water in northern part of the lake bed. Water level there are rising, and some fishings have returned. So this has not only affected the fishing industry, but the habitat or the people who were staying close to the coast of this Aral Sea, they also were forced to shift. So it is overall, it has affected the environment. So the lesson learned, this is important, lesson to be learned from Aral Sea is how quickly environmental damage can bring about regional change. Now, another example is the geomorphic system implication to climate change. So, the Earth's surface in action, mountain uplift and global cooling. How this is connected? Let's see. Is that the mountain building activity can also bring change in the climate. Of course, we all know that the Himalayas which were formed, so before the formation of Himalaya we were not having the monsoon season, but after the formation of Himalaya, towering height of the Himalaya which was achieved, we started getting the monsoon. So, of course, this can or have brought the changes in the environment and climate also. Now, coming to this point, that the uplift, so active mountain building process is linked to global climate change through airflow modification and in part through weathering. Young mountains weather and erode very quickly, and this erosion removes, or weathering processes removes carbon dioxide from the atmosphere by converting it to a soluble climate. The carbonates are then carried to the oceans where they are deposited and buried. So, in one way, the erosion of, because if you keep on increasing the height of any mountain, the erosion will be faster, and that erosion will result into the removal of carbon dioxide from atmosphere and convert it to the soluble carbonates, which will be further deposited to oceans and buried. It is possible that the growth of Himalaya scrubbed enough carbon dioxide from the atmosphere to cause a global climate cooling that culminate in quaternary ice ages. So, this has already happened, and this will happen in future because the mountain building activities continue. It has not stopped, the growth of the mountain is continuing. Our daily activities are having measurable effects on rainfall, climate, air, water quality, erosion, earth processes and landscapes too. So, this is the point which we have discussed, that to have a proper understanding of earth processes which are operating surrounding us and related landscape, that is geomorphology, it is essential to know various natural processes related to earth and its environment. Those are internal processes and external processes. Further, we study earth processes such as volcanism, glaciation, stream flows, rock formation, etc. We also study to understand the minerals, how they were formed, dissolved minerals, mineral resources, rock formation and groundwater. Physics to understand plate tectonics, volcanism. So, now we are towards the end of the introduction part. So, we are just trying to see the overall view of the talks which we did for the introduction part, that we need to study all this to have the proper understanding of the geomorphological landscape. So, earthquakes, landslides, biology to understand how life process integrate with other earth systems, how life is evolved, fossils and rocks. We need to know the drainage system on the earth's surface. So, meteorology to understand stream flows, groundwater levels, and this is connected with the floods and all that. Oceanography to understand seafloor role in plate tectonics, shoreline changes, but some of the aspects we are not going to talk in this course, but yes, of course, most of them we will be covering, as I told in the beginning, as per the course content. So, these are few more which are involved: astronomy, mathematics, computer sciences, economics, mineral energy resource and all that. And mainly the mineral and energy resource has been involved, or to understand, to know the, because the human will be involved in this resources. Okay. What do earth scientists do? Mainly they seek understanding of all processes that operates on and inside the earth. They study our planet long history, that what we call the historical geomorphology. Water bodies they study the processes, hazardous processes. They study rocks, spot surface pattern to understand the landscape change. Now, this is an example of physical and historical geomorphology. So, historical geomorphology mainly is the chronology of events, both physical and biological, that have occurred in the past. And the figure on the right hand side shows the evolution of the drainage over the time, where it shows youth, maturity and old age drainage. So, this is the chronology, so time scale of how the drainage was evolved over the time. The past is the biggest clue to the present. This is what we have been talking in since beginning, that present is the key to the past. So, past also can give us a clue about the present condition and future also. So, physical geography, so that is the part of the historical geography, and then physical geography, what we see, it is concerned with understanding the process and the materials. Now, let us see what is there in the energy and environment topic. So, earth energy balance, we will talk about greenhouse effect and global warming. And of course, in brief, if possible, we have been discussing about the greenhouse effect, and we have talked in couple of slides in the previous lecture also. Let us see earth energy balance. So, earth energy balance, earth receives energy from sun, and it also reflects as well as radiate energy back into the space. So, not all energy which has been coming from sun is been taken away by the earth surface or the earth. Some is reflected back, some is absorbed and transmitted back into the atmosphere, and some of the energy which is transmitted to the atmosphere is also reflected back, and that is how we are experiencing the greenhouse effect. So, Earth's energy budget describes net flow of energy into Earth in the form of incoming short waves and outgoing infrared long wave radiation into the space. It's important to understand climate change, because this will help us in understanding the landscape change also. All the energy that warms the atmosphere, oceans and land must be radiated back into the space in order to maintain our current climate. And if it is not done so, then we won't be able to support life on Earth. So, this is important part, that all energy which has been received or which warms the atmosphere, ocean and land must be radiated back. So we have different frequencies of electromagnetic waves or the radiation. So we have short waves which is coming in, and the long waves which has been poured out from the earth surface into the atmosphere. So short wave radiation, incoming and outgoing long wave radiation. So incoming radiation from sun, short wave radiation that occupies the frequency range of visible and ultraviolet radiation. Outgoing radiation from the earth is the long term radiation. So just keep this in mind. Now here, as I was talking about, that not all short wave which is coming in through the atmosphere is passed through and through to the earth's surface. Some gets absorbed within the atmosphere, some is reflected back from the atmosphere. It never reaches the earth's surface. And some which reaches the earth's surface, absorbed and radiated back to the atmosphere. So earth energy balance, if you take solar energy input to earth's surface is on average 342 watt per square meter. Heat flowing out of earth's deep interior, because there is another source of heat which flows out towards the earth's surface, and this heat flow has been transmitted to the atmosphere in terms of the long wave radiation. So heat flow from the deep interior is much smaller as compared to what we are receiving from the sun. Third is, to maintain a constant temperature, heat radiating from earth must balance the solar input. So the radiation which is going out should balance the input radiation, and that's how the energy balance will take place. Let's see how it's happened. Energy budget diagram shows the energy flow into and away from the earth. It is based on the measurement from the cloud and earth's energy system. So it is cloud and earth's radiate energy system, CERES. So this has been measured through a satellite instrument providing high accuracy of the radiating components. The total amount of incoming radiation is 340 watt per meter square. So radiated energy budget diagram, the calculation has been done based on the Stefan Beltzmann law of black body radiation. So where P is equal to sigma AT A T to the power 4, where P is the energy radiated in watts, sigma is Stefan constant, A is the surface area of the body, T is the temperature of the body in Kelvin. So reflected back by cloud, that is the energy which has been coming, that is from 340, 77 watt per meter square is reflected back by clouds, and the atmosphere 23 watts per meter square, around 7% of the total, is reflected by the surface. 70%, that is about 240 watt plus per meter square solar energy input to the earth. Absorbed by atmosphere is 77, almost 23%. The role of atmosphere, if the earth is without atmosphere, suppose we consider that the earth is without atmosphere, then all radiation it receives from sun will be reflected back into the atmosphere or the space, and in that case the effective emission temperature would be 255 Kelvin, which is minus 18 degrees centigrade, and this is the temperature which acts as a black body. So, actual mean temperature of the terrestrial surface, that is our surface, of 288 Kelvin, that is 18 degrees centigrade, is due to the presence of atmospheric absorption and re-radiation, that is the greenhouse effect. So, because of that we are having the 18 degrees centigrade temperature, which supports the life on the earth surface. Otherwise it will be, everything will act as a black body. Now, if you see the energy budget here and balance, so in total 340 or 341 watt per meter square is the incoming solar radiation. Now, out of that 79 watt per meter square has been reflected by cloud and atmosphere, and 23 is reflected back to the atmosphere from the surface of the earth. So, it takes away total 102, and on the other part 161 is absorbed by the surface, and again this absorption along with the greenhouse effect, the total is reflected back is 239. So, if you add 239 and 102 which is reflected back or which has been re-radiated back to the atmosphere, then it is equal to 340 or 341. This is another example which is similar to the previous one. So, greenhouse effect, mainly what we were talking about, that nothing is been so secured, not all waves or the electromagnetic waves which has been, or radiation which has been received is radiated back to the atmosphere, some is reflected back from the atmosphere to the earth surface, and some is directly or is reflected or re-radiated to the atmosphere. So, this part we have discussed. So, I will all quickly move. So, mainly the short wave radiation coming from the sun, and this is the glass surface which is covering the hut, acts as an atmosphere. So, short wave radiation is been received through the glass, and some which is radiated back, that is infrared, to the atmosphere, but cannot go through, is again re-radiated back to the earth surface, and this makes the warming, that is the greenhouse effect. And some long wave radiation which goes through the glass, and glass is very much similar to what has been we can compare to the atmosphere. So, in total this is the process which results into the greenhouse effect and warming of the earth surface. Radiation and temperature. So, this is an example of hot objects which radiate more energy than cool hotter objects with shorter wavelengths. So, basically the blue portion which you see here is your low temperature, and black is also of low temperature. So, blue, or either you say violet, and then red is your high temperature areas, and the yellow one. So, we will stop here and we will continue in the next lecture. Thank you so much.